Sweet. All right, we're going to do Advent of Code, day 5 in Rust. Wish me luck. Let's talk about the problem. Day 5, hydrothermal venture. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, your puzzle input for you to review. For example, there's a bunch of examples here. Each line of vents is given as a line segment in the form of x1, y1 to x2, y2, where x1, y1 are the coordinates of one end of the line segment and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. In other words, an entry like 1, 1, 1, 3 covers points 1, 1, 1, 2, and 1, 3. An entry like 9, 7, 7, 7 covers points 9, 7, 8, 7, 7, 7. For now, only consider horizontal and vertical lines. Lines where either x1 equals x2 or y1 equals y2. So the following horizontal and vertical lines from the above list would produce the following diagram. And there's an example here. In this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point or period if no line covers that point. The top left pair of ones, for example, comes from 2, 2, 2, 1. The very bottom row is formed by the overlapping lines 0, 9, 5, 9 and 0, 9, 2, 9. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. Consider only horizontal and vertical lines. At how many points do at least 2 lines overlap? Okay. All right, so to just think about this problem a little bit abstractly, it feels like what we do is just keep basically a grid of integers, and we loop over our lines and essentially draw the lines into the grid. This is basically, we're implementing a primitive drawing program, except we're not actually visualizing that anyway unless we want to just render it to a string or something like that. And as we draw, we're also keeping account of the number of times we draw to a certain cell of the grid, or to a kind of pixel, if you will. And we're also trying to filter out any lines that are diagonal, basically. So that seems pretty straightforward. It seems like maybe just like yesterday, the big challenge, at least in Rust, is just to make sure that we parse the data correctly. I'm just going to take a quick look at the data. And it looks like our numbers are quite big here. So let's go ahead and set up our day 5A project. We're just going to copy our template. Now that that exists, I'm going to go ahead and just update my manifest file. And let's just make sure that runs. Okay, it runs. I'm going to reload my editor real quick because I need to do that to make sure that the language services work correctly in the new folder. And away we go. All right, let's grab our input. I'm going to copy that, paste it into our input file. Now that we've done that, it should print out all of our input. Luckily, I think this is going to be a little bit easier to parse than it was yesterday because each line is pretty consistent. What we can do is just iterate over the lines, split them by this kind of arrow delimiter, and then split the resulting chunks by commas. Let's go with that. And how do we want to actually represent these points? Could be a tuple of tuples. We could actually make a struct. Maybe the struct will actually just make it a little bit more clear. What am I doing? I'm doing C, or C sharp. Does it want commas? It wants commas. Great. Okie doke. Let's go ahead and start doing these parse. So a line is basically just going to be described as 2 points. we could maybe, let's just do A, which is a point. B, it's also a point. So we're going to say that we have our lines, which is a vector of points. And it's going to equal our input, and we're going to split that into lines. I think we're going to have to like basically keep the input in a temporary variable for now. Just so that it doesn't get dropped in Rust. Input.lines. And what we're going to do is we're going to map over this. Give us a line, which is a string. And this is going to be the interesting piece of code here. So with that, we're going to basically take this and split it along this string. And then here, we're going to basically get two chunks. And the split is going to be an iterator. So let's go ahead and collect these into a vector. All right, it is complaining here. I think it might just be complaining because we're not returning the right value just yet. It's pretty noisy. So what we're going to do is try to parse each chunk. We're going to split that by a comma. Let's see, the strings for A is also going to be a vector of, let's call this a vector of I64s, right? And we're going to split those, map it, and this is going to be essentially a number. And what we want to do is like parse this, unwrap it, and collect it. And then we're going to do the same thing with B. And then we're going to create our line. This is going to be A0, Y is going to be A1. That's B, B, and B. All right, do we have a parsing error? So this is supposed to be a vector of points, so we got to collect them at the end. And that did it, I think. Value of type vec point cannot be built from an iterator over elements of type line. Trait from iterator line is not in. Okay, so why is it returning lines? Hey, how's it going? Low Coffee. You should get some coffee, Low Coffee. Thanks for joining the chat. Lines. I think what it is I wanted a vector of lines. That's basically it. Just a little typo. Okay, so it looks like we're parsing correctly. Just to make sure that we're doing it right, I think I'm going to go ahead and just derive some debug here. And really, these should all just be clone and copy. It's kind of boilerplate for kind of value structs like this. Low Coffee, I am doing well. Thank you for asking. How are you doing? Are you also doing Advent of Code this year? Okay, we've got our lines. Let's go ahead and verify that we've parsed it correctly real quick. I'm just going to take a look at this last line here. which goes from x 764 830 to x 91 157. Let's take a look at the input. 764 830 91 157. Okay, it looks like we're parsing it correctly. Okay, the next thing we need to do is we actually want to filter these because we don't want the diagonal ones. So what I'm going to do just for now is I'm going to just stick a filter in here. And we are going to receive in the filter, I guess it's a line. And the logic we want to return is as long as either the x coordinates or the y coordinates are the same, we're going to keep them. Right. Low Coffee, you're not doing Advent of Code. Well, I'm glad that you're watching anyway. Anyways, we're doing day 5 today. If you're not familiar with what Advent of Code is, it's a kind of, it's not really a competition. There is a leaderboard, but basically it's just like an Advent calendar for programming problems. You basically get a programming problem every day in the month of December, and I just do it for fun. People do a leaderboard, and there are just some real demons out there that can solve these problems in like 10 minutes straight. That's definitely not me. It'll probably take me an hour or two to finish this one today. Anyways, let's go ahead and continue and do our filter here. So what we want is that line A dot X is equal to line B dot X, or that line A dot Y is equal to line B dot Y, right? And let's slim that down a little bit. Okay, so that should just give us the horizontal lines. And I wonder if I can find a diagonal right away near the top or bottom that I can go ahead and just assume is not going to be included. I don't think it's easy to eyeball the diagonals here, but we know that we have 500 lines specified here, and so what I can do is just print the number of lines here and just make sure that we get fewer than 500. 339. Okay, great. So I'm just assuming that that's going to work correctly. And so now what we want to do is we want to plot these lines in some kind of grid, right? So it looks like the lines are all positive numbers. In fact, we don't need to make the full grid. What we can do is we can make a hash set, essentially just like a hash table that is keyed by the coordinates. And that will be a much more memory efficient and kind of fast thing to work with. Just because the grid will be really, really sparse. And we don't know how big it needs to be. Like, we could basically look at the numbers and just say, okay, it probably needs to be like 1,000 by 1,000 because it looks like we're just looking at 3 digits here. But like, I don't know. I think maybe the hash set will be a little bit easier to work with. So let's go ahead and do that. The counts is going to be a hash map, rather. And the key is going to be the tuple of, well, I guess it's going to be a point, really. And then it's going to be some count here. Right. I'm using i64. We could use usize, but I feel like usize, I kind of just use as iterator indices. Not sure what the subtlety there is. There's probably a whole philosophy on when you should use unsigned values and usize versus signed values. But I'm not gonna stress myself out too much with it. All right. So we're gonna go ahead and iterate over all of our lines. And then we will, and let's do an iter here, just so we get references. And then we need to actually figure out just how to like basically increment our counts. And the actual problem prompt here, if we can basically refresh our memories, the actual problem prompt is just how many points do at least 2 lines overlap. So we really just need to, this really just needs to be a Boolean of whether something was there before. Right? And then let overlap count equals 0. And let's make these both mutable. No, we're going to need that. And so what we're going to do is just iterate over the points here. Okay, so we actually need to decide how we're going to iterate. Are we going to iterate over the x-axis or iterate over the y-axis? And I'm just going to do this in a super brute force simplistic way. So if line a.x does not equal line b.x, we know that this is a horizontal line. And so we are going to be iterating over, if it's a horizontal line, that means that the x values are not the same. And we're going to be iterating over the x-axis because we know the y values are the same. Otherwise, it's a vertical line. And so what we'll do here is we'll just say for line.a.x, for I in line.a.x, to line.b.x, and I think we're including, I believe this notation in Rust is going to include b.x, although I think it's maybe having a hard time with my range notation here. Exclusive range. Oh, we don't want an exclusive range. We want an inclusive range, and there's no triple ellipsis in Rust. And really, what this we should call this variable x, I think. And let's just say just to be super clear, our y value is just going to be a.y. We pick it. A and b are going to be exactly the same thing. We could even add an assertion there if we wanted to, but I don't think that's necessary. Okay, so what we're going to do here is, I don't want to double count these, so actually I think I'm just going to have what I originally had here, I64. I was originally just going to say, is there something in the hash map at that point? But the problem with that is that you could double count it for the third time you go over that point or the fourth time you go over that point. So we're going to ignore doing that. All right, so let's do that. Counts. I believe there's a way we can do counts of the point x, y. Cannot index into a value type of hash map point. Okay, so maybe hash maps don't have, I don't know if it has that operator. So what if we do get mute of the point x, y, and we add 1 to it? Is that going to be satisfied? Add a reference here. Okay, I see. Get mute. So we need to do kind of something like this, match. And is it okay for an optional? Okay and none, I believe. We want to do count plus equals 1, none, counts dot insert. I think if we get it mutably here, it's going to have an issue with us trying to mutate it here. So I think I can't be quite this clever. So what we want to do is we just want to say if counts dot contains key, and unfortunately we're just going to have to do this. let P equals this. If it contains it, we want to let C equal counts dot get mute. Or how about this? Let's get the value. Hey, Arisa Snowbell, it's good to see you again. Standard hash map enum entry. Oh yeah, I can totally do the entry thing. That's actually good. Like this is I remember seeing this a couple years ago, but I never really learned how to use that. So let's check that out. I probably have to specify that it's Rust. So I can fetch an entry. And I think this will basically, I think what we're going for is to do something like a set, or either set a value or modify it. That's basically what we want. Yes, get the entry for in-place manipulation. That's what we want. And the entry, what if it doesn't exist? Will it create the entry? Oh, it has an or insert. Perfect. Got it. So entry returns the entry, but or insert also adds the entry. Okay, and it lets you set a default value. This is perfect. Thanks. This is great. It cleans up the code considerably. So I'll just say the entry equals counts.entry of my point, or we insert a 0, and then we say entry with a dereference plus equals 1. And this is complaining because the point doesn't hash. So I think I need to make it's a hash. Yeah, right. And it's still complaining. Doesn't equal. I think I need to do partial equal. Yeah. And that should do it. Still not. What is it complaining about now? Expects the point. I'm trying to think of. It doesn't need a reference because it's just hashing it. I think that's why. Yeah. Oh, and Arisa Snowbell says map.entry something and modify or insert. That's super cool. I like there's so much like extra handy dot stuff in I guess it's like all ML inspired languages have this. OCaml, but Rust has a lot of ML influence as well. Let's try the suggestion that Arisa Snowbell is offering here. Arisa Snowbell, I'm really appreciative of you offering this stuff because I am learning a lot about Rust, and hopefully I won't forget too much about it this time. And if we really want to golf it down, we can just pass the key value in here, and that looks pretty nice, right? And I don't even need to assign the entry local variable anymore. That's pretty good. This is a really, really pretty piece of code right here. I like it. Now, what I haven't done so elegantly is I have to do a little bit of repetition here, but I'm not too busted up about it. I guess what I could do is, well, it's the iteration that matters here. So that's the tricky part. So I'm just gonna swap these x and y here. For a vertical line, we're iterating over y values. For a horizontal line, we're iterating over x values. Yeah. I'm sure there's probably a way that we could be clever and sort of swap these up, but I actually think that this is pretty clear about what the intention is here. I think I'm not really like code brevity isn't always my number one priority, I think. Okay, so now that we're here, the actual thing we're trying to do is just trying to find all the values in the hash map whose value is greater than or equal to 2. So I think we can just do let overlaps equal to our hash map. And what I want to do is iterate over these and fold them. And our initial value is 0, and our accumulator's here. And what exactly is the iterator over? It's a tuple of references to the keys and values, which is totally fine. I don't need the key. What I want is the value, which is the count. And my accumulator will be, if the count is greater than or equal to 2, we're going to just add 1 to the accumulator. Otherwise, it's just the accumulator, right? The other thing we could do is actually do a filter over the filter first, a map and then a filter. And maybe that will be a little bit cleaner. I wouldn't have to have this like cumbersome if else. So the map will be over a key and a count, and we're just returning the count. We're going to filter out. Oh, I forgot my extra pipe here. We're going to filter out counts. We're going to keep counts that are greater than or equal to 2, or let's just say greater than 1. Well, let's do greater than or equal to 2. I like using the exact number. I like the number literal that's presented in the prompt. And then we're going to fold over these. It's going to start at 0, and then we're going to have an accumulator. We're going to have some value that we don't care about, and we're just adding 1 to this. Right? It's greater than or equal to 2. I think I just need to do a couple of dereferences here. And actually, I don't even need to fold here. I just need to pass a count. I just need to count these. Right, and then I think that will be it. Okay, so it looks like it type checks, so let's just go ahead and run this. 27. Let's just give that a shot. Okay, not the right answer. They're not giving me a hint of whether it's too high or too low. So anytime we do this, that's fine. Let's just go ahead and take a look at the sample input. And we'll run it here. And we got 0 here. Okay, so somehow we have some false negatives in some filtering step here. And we need to figure out what that is. I think one thing we can do is just print out the lines that we're getting here and making sure that we're doing this first part correctly. I have a suspicion that it's going to be fine, but let's take a look. Okay, the lines we get. Let me actually print out the number of lines, because I think that's going to be a little bit easier to reason about. 6 lines. One, 2, 3, 4. One, 2, 3, 4. So what's interesting is at this point we have too many entries, it looks like. So I guess we can just eyeball it here. What? Maybe instead of or, it should be and in the filter. Line A equals X. If it's and, what I think that will mean is that essentially the lines are identical, right? Because that means that the X value for the points and the Y values for both points will be the same. So what I think that would say if we used it a Boolean and, yeah, I think you get what I'm getting at here. So it could be though that I did a parsing error, right? Which is not unheard of. I think parsing for me is actually the trickiest part of doing this sometimes. And it's also because I just don't know the language very well, right? And so it's easy for me to kind of flub it. Am I filtering diagonal lines? Well, that's the intention of the filter on line 37 here is that we're saying that if the points share the same x value or if they share the same y value, then the line is not diagonal, right? So I'm just going to try to sanity check my input here a little bit. So let's just go ahead and blow this up here. And then what I'm going to do is it thinks this is TypeScript. So it's just text, just plain text. Don't give me complaints here. I'm going to replace this. How do I get a new line? I think I need to actually copy it. Boy, this is cumbersome. Just make this a little bit more legible. Actually, what I probably wanted was this. Copy that new line, paste it in the find and replace, and that's a little bit easier to read. 0959, and we're taking a look at the input. 09 to 59. 94 to 34. Okay, I mean, just eyeballing these, they look correct. Am I misinterpreting the example? How's it going, SureShack55? What's the problem? The problem is that, well, I'm actually trying to determine what the problem is. My program currently isn't producing the same value as the sample input. And so I'm just trying to interpret what's going on here. I think maybe I'm getting, when I use the sample input, I'm getting 6 lines that aren't diagonal out of this. And so in this diagram, there's 1, 2, 3, 4, I guess, because this one, is there one that's just 1 point? Like, how is this a 2 right here, unless there's a entry with 1 point in it? Diagonal lines comes in part 2, not in part 1. I agree. Yeah, we're just trying to filter out the diagonal lines and making sure that we're doing that correctly. 1, 2, 3, 4, 5, 6. Let's see. Do I see something in here that has the same starting point and ending point? Like, what the heck is this? And where is this coming from? This 1, 2 right here. Because the implication there... Oh, you know what it is? I'm just misreading this. This is probably like 2 disjoint lines that are next to each other. That's what I'm seeing here. Yeah, I mean, it's an intersection. I think what I was misinterpreting is that all these 1s came from a single line, which is not the case. Right? We could have basically a line segment here and a line segment here. Or this is probably all 1 line segment. So that's 1, 2, 3, 4, 5, 6. Okay, I'm convinced that there's like... that maybe our parsing is at least correct here. Or I'm not 100% convinced, but I'm like 90% sure. So maybe the logic then is in the way that we're actually like plotting these things, right? Okay, so we go over our lines here, and currently when we run this with our sample input, we're getting 0 back, right? Which is not right. What it should be is 5, right? So there's something we think wrong here. So let's see what we've got. If AX does not equal BX, the X values aren't the same. We know that we've filtered out the diagonals. So that should be a horizontal line. And this should be this. And then for X, I guess one thing we could do is just print out the hash map and or visualize it, right? That's one thing we could do. You know what it is? Our insert should be 1. That's probably our logic error. Well, that came out 3. That's disappointing. That was like a little bit better. But we want 5. I was so happy when I saw that bug, and no, it's not the right one. Right now, I'm just checking for like silly mistakes right now. If I've kind of, put an X where there should be a Y or an A where there should be a B. The other thing that I'm thinking is that what I need to do is like use the minimum and maximum of AX and BX because we're not sure if the lines are sorted correctly, right? So let's at least try to add that in there rather than just try to visualize it because I actually think that printing this out would be kind of like a painful exercise. What we can do is we can just set let min equals the, is it i64.min? Yes, line a dot x, line b dot x. And same with the max. You can use min directly. Okay, yeah, I can pass references. Yeah, because it doesn't look like this is actually work. It looks like what you're saying, SureShark 55, is that it's probably like exactly how you're supposed to use it. Because using it in like a static style like I was there is just not working. So, or at least the analyzer is complaining about it. You know what? A min and max for i64, you don't need to pass references. It looks like it just does it by value, which makes sense. So instead here we're going to do min dot equals max. And then similarly over here, actually let me just copy this whole thing and be very careful about replacing our variables here. All of our x's basically should be y's. And let's run that again, and that gives us 5. Okay, let's try it again with our actual input. 6,461. Wow, that's way bigger. But I got it. Okay, that was some nice bug fixing. Good job, team. Thank you very much for the tips. Let's just get this in a Git. Just gonna copy that bad boy. And now they got 5B. Just gonna do a quick little rename. There's probably some boilerplate out there that makes this a little bit faster, but I wrote this, I understand how it works, and sometimes that's just the more comfortable position to be in. All right, I'm gonna go ahead and close everything out. Open up my main.rs for day 5, and let's take a look at the prompt for day 5. As SureShark was saying, it's probably going to involve our diagonals. Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You need to also consider diagonal lines. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only be horizontal, vertical, or diagonal at exactly 45 degrees. I'm glad. I was like kind of thinking in my head, is this going to be exactly 45 degrees? Because otherwise we'd have to do some kind of like discrete line drawing algorithm, Bressenham or something like that, which is just stuff that I always like kind of read about, but never really was able to get into my head. So I'm glad they're just 45 degrees because this is easy to plot in a grid. Okay. You still need to determine the number of points where at least 2 lines overlap. In the above example, this is still anywhere in the diagram with a 2 or larger, now a total of 12 points. Okay, so this isn't too bad. I think what this is asking us to do is to make a generalization of the code that we've written here essentially so that we're just marching through X and Y correctly. And so there's probably a way that we can do this generically. But it might be easier to specify. Like, basically what we want to do is loop over the X's and loop over the Y's. Sure, Shaq, do I need a hint? I think I have an idea of how to do it in my head, but you can let... the backseating is totally fine. I'm really happy to have company while I'm doing this problem. But let me give you this. If you see me floundering and you can't take it anymore, feel free to chime in and give me a little bit of a hint. I do like trying to figure these out by myself, and so if it starts to get painful for you, then you can drop me a little bit of a hint. But I think I have an intuition of how to do this in a way that will reduce all this code to just basically one kind of chunk of code. I think one thing I was sort of like considering last for the previous problem was that, like, oh, this is kind of ugly that I'm repeating this. But I think what we can do is, first of all, we get rid of this filter here. We don't need to filter out diagonal lines anymore. And so for each line, what we can do is we can just have something like this, right? But instead, it's going to actually be the like x min and x max, right? And then we're going to do something the same with the y's. And then what we're going to do is we're going to just do a for loop over the x min, x in, x min to x max, and then a for loop over y in, y min, y max, right? And then I think this should do it. SureShark has a suspicion that it's not going to work. I'm going to just run it and we can verify. Oh, wait. This is actually doing squares, right? For part one, I think it might work. What this is, I think what SureShark is saying is that we right now, we're basically plotting a square. And what we want to do is plot the diagonal, right? This is plotting a whole area, and that's why it was taking so long to run, right? And what we really need is we want to advance x when we advance y on the diagonals. Yeah. Now, is there a way to genericize? I think that I don't think there really is a way to genericize it unless we add like some accounting for the slope of the line, which I think is actually kind of painful. That is actually, I think, if we were talking about like a Bressenham line drawing algorithm, that's essentially what you're doing there. So what I think I'm going to just do is just account for diagonals in a separate case. Let's just not be too fancy about it, right? And let's just think about diagonals separately, just so we're not cluttering our logic with the rest of this stuff. Here we know that the x's and y's, if it's diagonal, then we just advance x and y the same way. So what we're going to be doing here is, I wish I didn't delete my x min and x max. Let's just have these on hand, right? And then what we're really just going to do is just advance x and y by 1, right? Yeah, so we're going to go from, I mean, we could just do for I in 0 to x min, x max minus x min. And I think it's going to be inclusive, right? Or it could be +1. This is an area where it's going to be like easy to be off by 1. And what we're just going to do is advance both x min and y min by I and add to the counts, right? So what we could do is something like this. But our point is actually going to be x min plus I and y min plus I. And we just need to make sure that we're not off by 1, right? And we don't even need y max at this point. And this gives us a diagonal line because we're just advancing by 45 degrees every time. So let me just make sure that we're doing this correctly. If the 2 points were exactly the same, x max and x min, the difference between them would be 0. But we would want to at least run the iteration once. So I think we do want an inclusive loop here, right? So let's give that a shot. Let's hopefully it's not going to run forever. All right, it was pretty quick, 18,832. Not the right answer, it's too high. Okay. Okay, well, I think we can trust this code. I did do an undo here, but I feel like it's reasonably trustworthy. I just got rid of the filter up here. So the bug is probably located here, right? Let's take a quick look at the prompt one more time. Just make sure we're not missing anything silly. Unfortunately, considering only horizontal and vertical lines doesn't do it. You need to consider diagonal lines. The lines will be diagonal at 45 degrees. Your current code doesn't account for negative direction. Right, so I think what we're talking about here is I'm doing minimum and I'm doing min and max here. So the problem is if you're starting, oh, I see what you're saying. If basically like, if x and y advance in different directions, right, from point to point. Yeah, totally. Maybe what this means then is we need to come up with an x increment and a y increment, right? So something like dx equal line a dot, if we just start on this, a dot x, it's really actually going to be b minus, if we consider a, if we treat a as the origin, it's line b minus line a, and our dy is going to be this. And then just the number of times we go is just the difference, the absolute value of the difference. And rather than going from the minimum here, we're just going to go from line a dot x plus I times dx. Not dx. We just want the sign of it, right? We just want the sign, whether it's negative or positive. Is there a sign? It's so trivial that like they probably wouldn't include it. I know floating point libraries oftentimes have like a sign function on it. Like what is like, am I positive or negative? Right. Signum should give it. Okay. I don't even recognize Signum, so that's good to know about. Signum returns a number representing the sign of self. Okay, perfect. Yeah, so I guess we don't even need the y minimum here. And the only reason why I have x min and x max, I guess x min and x max is literally like the same value as this. Because we're just trying to look for the difference, or just basically how long the line is going to be, right? Why don't we just repeat this, and then we can get rid of these extra variables, and then we multiply this by. It's not really dx dy. I guess it's dx dy because it's basically the increment per. It's like the marginal change in each of these variables, right? All right, let's give that a shot. And hopefully we're getting a smaller number than 18,000. No, it's exactly the same. That's actually surprising. I would have thought that we would have accounted for that. So I think even the intro, even the sort of sample has an example. I think this is what Shirshak was pointing at, where the x value decreases, but the y value increases. So I should be able to like essentially reproduce some kind of. If I just plug in the sample input, we're going to get something that gives us the wrong answer, right? 18. And so this should overcount, right? Yeah, it's overcounting because the actual answer is 12. Check if you're getting 7, 7, 7, 8, 8, and 7, 9 when you use second input. Yeah, I guess what Shirshak is saying is, why don't I just print these? You can wrap it with a debug macro. I'm not familiar with that macro. What do I wrap? Is it just the? Is it just this? I don't have to write this little like crazy. That's cool. I didn't get any output. Am I just do it? I did derive debug here. Maybe what it is I'm suppressing standard error or something like that. No, it's just not printing at all. Wait, am I even getting anything here? Am I even reaching this code? I think that's basically like, let me just type something here just to make sure that this code is even getting called. Oh, I think I'm just not accounting for diagonals correctly here. These conditions no longer are true because diagonals have to be there. So basically we have to do a like line a dot y equals line b dot y, and line a dot x equals line b dot x. Otherwise, we get to here, because basically the diagonal lines were getting swallowed by these vertical and horizontal line sections here. So I'm just going to check this out. 12. Okay, that's looking a little more accurate. I think that is the answer that we were looking for the sample input. Okay, so Shurshak, you're saying debug inside the entry like that. Yeah, totally. I just can see how that's like really useful. You can pass it in closures, I think is what you're saying. Oh, I see. And debug returns the value that you pass into it as well. Is that what you're implying there? That I could see how that'd be really, really handy. Yeah. 18,065. Okay, that's slightly lower than I think what we got before. I don't remember what we had. I think 832 or something like that. So let's check this out and see if that's the right answer. All right, that was it. You know, it's so funny when I got into part 2, I was like, oh, this is just going to be a very simple extension of part 1. And I think we could say it was a relatively simple one relative to, like, sometimes part 2 can be a real bear. But there's enough subtle here that, like, you know, got me tripped up a little bit. Okay, well, that is Advent of Code Day 5. Arisa Snowbell, thanks again for spending part of your weekend with me. And Shurshak, really helpful. I learned a lot about Rust today from you folks. And hopefully I'll have a chance to chat with you folks again in the future. We'll see if I'm able to actually work on this tonight. I've always wanted to do these problems as soon as the problems drop, but sometimes you just want to play video games, you know? It's a school night. Okay, all right. Take care, everybody. By the way, maybe try without any semicolons. Oh, that's an interesting challenge. So I think basically what you're saying is let's do it maybe like in a more functional style that Rust affords. Yeah, we could totally do that. It's not. I guess I don't know idiomatic Rust. I'm really kind of writing this the way that I would just kind of do this in, I suppose, any other language. Very, very brute force iterative style. If nice, Shurshak. You did day 4 in a like. Let's take a look. Actually, I hope you don't mind if I do a little bit, not code review, but I just like kind of check out what you're talking about here. Let's take a look. No semicolon Rust. Nice. Yeah, totally. So it's all dots. I did it one year in OCaml, and I really tried hard not to use any imperative code. So basically no semicolons, no statements. And it ended up looking really, really similar to this. Lots of indentation. And OCaml also, like, I guess syntactically is just a little bit less conventional to most people's eyes, including my own. And so it was really hard to read. But this is really, really nice. It's nice that you can kind of like chain things together like this. I think, you know, just looking at this, I can see why having that debug macro would be really useful, because I think one of the problems with the dot chaining style is like, if you want to pass the result into a printf, you know, in any other language or in other cases, you'd want to be able to like essentially store the result of a computation in a temporary, so you can print it, or you can do some kind of like debug work with it, you know. But it sounds like what that debug macro is going to give you is the ability to do this kind of like dot chain style while being able to like essentially print stuff out during iteration, which is really nice. Yeah, I might give this a shot. I think I'm still trying, like, as you can tell, I'm still trying to get my sea legs again with Rust. Just even knowing that what functions exist in the standard library. It's such a complicated language. Fun to work with. Great for modeling problems, ironically. I think it's actually really good because everything is like default const. You have enums that can have payloads in them. I think that's all really, really nice. But it's enough for me to keep my head above water with the borrow checker and the lifetime checker at this point. But yeah, this is a great reference. I'll be sure to check out your repo in the future. So thanks again, Shurshak. This is a really nice resource. Take care, everybody.